Hello everyone, so today we're going to go over section 9.3 part A, solving exponential equations. We'll begin with some review of the exponent laws. So if we're given the power x to the n, we know that x is the base and n is the exponent. And x to the n is a power. So some exponent laws that we need to know in order to solve exponential equations. Starting with the product law, so x to the m power times x to the n power is equal to x to the m plus n power. Likewise, we have the quotient law, so if we were to divide those two powers instead, we take the difference of the exponents. Okay. Next, if we have power of a power, so for example, x to the m to the n power, we can multiply the exponents together. Whereas if we have a quotient x over y all to the m power, then that is the same as x to the m over y to the m. Next, we have the power of a product. So if we have x times y to the m power, that would be the same as x to the m power, and then multiplied by y to the m power. If we have a base that is not 0, and the exponent is 0, then x to the 0 power is equal to 1. Next up, if we have x to the negative m power, then here we have the reciprocal. So that's equal to 1 over x to the m. And finally, if we have a rational exponents, for example, x to the m over n power, then that is the same as x to the m power and to the nth root. Oops, sorry. We could also take the nth root first and then raise that to the m power. The second variation is more likely in order to keep the numbers small. So one of the things that we can use the exponent laws for is to rewrite exponential expressions. So in this example, we're going to rewrite each expression using only positive exponents and with no parentheses. So in this first case, we have 1/2 and then y to the negative 6th power. This can be rewritten as 1 over 2y to the 6th power. So that's a 1 and 2y to the 6th power. Okay, since the negative exponents allows us to just take the reciprocal. So part B, very similar. Both the exponents on the x variable and the y variable are negative, so we take the reciprocal of each one. So we end up with 5y squared over x cubed. Just like that. Next one. So here we can multiply the coefficients together. So 4 times 2 is equal to 8. We have two powers of the same base of x being multiplied together, so we can add their exponents. So that will be 3 plus negative 2, of course. And then likewise for the y, we have 1 plus 2. So we end up with 8x and then y cubed. Next question here, we have a power of a power. So we have 3 cubed, which is 27, x squared and then cubed, so that will be x to the 6th power. We multiply the exponents together, and then y to the 9th power. 3 times 3 is equal to 9. Next up, here we're dividing, so we can subtract the exponent, but we'll start by dividing the coefficient. So 12 times 3 is 4, and then this will be b to the negative 1/2 minus 1. Okay, so that could be rewritten as 4 and then b to the negative 3 over 2. So the negative exponent means that we can take the reciprocal, places it into the denominator of our expression here, and then the 3 over 2 power means that we have the square root of b cubed in the denominator. So like so. Next question. So this one is a little bit more complex because it is rational, the expression, and also has a negative exponent on the outside of the parentheses. So we'll first apply this negative exponent here. So that will give us the reciprocal, so 4 over 3 instead of 3 over 4. And then this will be x to the negative 3 and then y squared. And on the outside, we just have the square. So next, we have this negative exponent here. So we're going to move that term to the denominator. Let's go ahead and do that. So this will be 4 in the numerator, and then 3 x cubed y squared, and then all squared. So complete the question. Sorry, to complete the question, we're going to square every term on the inside of the parentheses. So 4 squared is 16, 3 squared is 9, x cubed squared is x to the 6th power, and finally y squared squared is y to the 4th power. So for example 1f, the expression does not have to be simplified in that particular order. There are other ways to do the question, but this one seems the easiest to explain, so that's the reason why it is used here. Okay, so example 2. So here we're going to evaluate some expression without using a calculator. Okay, so let's see here. The first one, 2 to the negative 3 power, that will be the same as 1 over 2 cubed, which of course is just 1 over 8. So just like that. Second one, 81 to the 3/4 power, so that would be the 4th root of 81, and then cubed. So the 4th root of 81 is 3, so we just have 3 cubed, which is 27. Next up, we have 25 to the 0 power. Since 25 is not 0, raised to the 0 power gives us 1. And finally, we have 16 to the negative 1/2 power, so that will be the same as 1 over 16 to the 1/2 power. Like so, which of course is the same as 1 over the square root of 16. Sorry about that. Right, which is just 1/4. Okay. So in order to solve exponential equations, one of the rules that we'll be using is the change of base. That is to say, we're going to rewrite exponential expression with oftentimes a simpler base. So for example, instead of 9 to the 2x power, we can rewrite 9 as 3 squared. So we have 3 squared to the 2x power, which of course is just 3 to the 4x power. Next up, very similarly, instead of 125, we can rewrite that as 5 cubed. And then using the power of a power rule and also the distributive property, we can rewrite this as 5 to the 6 minus 3x power. Okay, next up, we can write both 8 and 16 as base 2, so 2 cubed is 8. And of course, 2 to the 4th power is 16. So that would be 2 cubed times 2 to the 4x. And since we have 2 powers of the same base, we can add the exponents together. So finally, this can be rewritten as 2 to the 3 plus 4x. Okay, the last one, very similar kind of deal. We can rewrite 16 over 81 as 2 over 3 to the 4th power. And then we have x plus 5 on the outside. So we can rewrite this as 2 over 3 to the power of 4x plus 20. Again, using the distributive property there. Okay, so with the change of bases in mind, now we can solve some exponential equation using a common base. Let's look at the first example here. So instead of 64 and 16, we can rewrite 64 as 4 to the 3rd power, and then to the 4x. On the right-hand side, 16, of course, is also 4 squared, and then x plus 5 on the outside. So that is the same as, oh, sorry about this equal sign here. So this would be the same as 4 to the 12x on the left-hand side. On the right-hand side, we're going to have 4 to the 2x plus 10, which really just means that 12x is equal to 2x plus 10 on the right-hand side. And now we can just solve this equation for x. We have 10x is equal to 10, and so x is equal to 1. Okay, so second example, we're going to use base 2 here, so this would be 2 to the 3rd power, and then x plus 2. And then 0.25, is, of course, is equal to 1/4, which of course is equal to 2 to the negative 2 power. So we can rewrite using that. So now on the left-hand side, we just have 3 and then x plus 2. On the right-hand side, we have negative 2 and then x plus 3. So now we can apply the distributive property. 3x plus 6 on the left-hand side is equal to negative 2x minus 6 on the right-hand side. So that is to say 5x is equal to negative 12. So x must be equal to negative 12 over 5. Okay. Third example is slightly different. We're going to divide both sides by 5 first. So that means the left-hand side is going to be 3 to the x power. And the right-hand side is going to be 27. So of course 3x on the left-hand side. 27 as power of 3 is 3 to the third power, so x is just equal to 3 in that case. Okay, so there's a few more examples, a little bit more sophisticated ones on the next page here. First one, we have 27 and 81 as our base for now. So a common base would be 3, of course. So on the left-hand side, we have 3, sorry about that, 3 cubed, and then to the x minus 2 power. On the right-hand side, we have essentially 1 over 81, so that's 3 to the negative 4 power, and then x plus 3. So that means we have on the left-hand side the expression of 3 and then times x minus 2. On the right-hand side, we have negative 4 times x plus 3. Okay, so that means on the left-hand side, we have 3x minus 6. The right-hand side, we have negative 4x minus 12. So moving all the terms containing x to the left-hand side gives us 7x. Moving all the constants to the right-hand side gives us negative 6. So that will be x is equal to negative 6 over 7. Okay, so this last one, a couple of different things going on. 125 and 216 are, of course, related to 5 and 6 respectively, so we can rewrite this as 5 over 6 cubed, and then to the negative 1/4 power. And then to make the right-hand side's base match, we can rewrite this as 5 over 6 to the negative 1. That way we get the reciprocal of 6 over 5. And then to the 3x minus 3. So that is to say, on the left-hand side, we just have 3 times negative 1/4. And then on the right-hand side, we have negative and then 3x plus 3. Sorry, minus 3. Okay, so further simplifying, we have negative 3/4 on the left-hand side, and then negative 3x plus 3 on the right. We're going to multiply everything just by 4 to clear out the denominators here, make things a little bit simpler. Okay, so we have negative 3 is equal to negative 12x plus 12. So subtracting 12 on both sides gives us negative 15 is equal to negative 12x. And finally, dividing both sides by negative 12 will give us x equals to negative 15 over negative 12, or just 5 over 4. Okay, so the only other kind of question that really appears in this section are the ones that involve radicals of some kind. And the idea, of course, is to rewrite radicals in their exponential form in order to complete these questions. So let's look at the first one of these. We have 2 to the x on the left-hand side. On the right-hand side, we want base 2. So 2 squared, we know is equal to 4. And the square root of 2 is equal to 2 to the 1/2 power. On the right-hand side, we have 2 powers of the same base, so we can add the exponents together. So that's 2 to the 2.5 power, which simplifies really to just x equals to 2 and 1/2. Okay, so similar kind of idea for question number 2. So on the left-hand side, we have 3 to the 1/2 power for the square root of 3. And then outside of that, we have x minus 1. On the right-hand side, 9 is, of course, 3 squared. And then the cube root means that we have the exponent 3 to the power of 2 over 3. the 2 being the square, and the 3 being the cube root. Okay, so that means that on the left-hand side we have 1/2 and then x minus 1. On the right-hand side we simply have 2 over 3. So, just like before, we can multiply both sides, in this case by 6. That will simplify the expression to 3 and then x minus 1 on the left-hand side, and 4 on the right-hand side. So we can now distribute the 3. 3x minus 3 is equal to 4. And from there, that means 3x is equal to 7. And of course, x is equal to 7 over 3 at the end. So example C is very much alike example A. So again, we have 2 to the x on the left-hand side. On the right-hand side, we have 2 cubed because of the 8, multiplied by 2 to the 1/3 power. Now, this one is a bit tricky on a test because sometimes we end up multiplying the 3 and the 1/3 together to get 1, which is of course not what happens. When we have 2 powers of the same base, we don't multiply the exponents together, we add the exponents together. So this would be actually 2 to the 3 and 1/3 power. So x is equal to 3 1/3. Okay. Last question. So we have 125 as one of the base and 625 as the other. So of course the idea here, the common base is going to be 5. So on the left-hand side, we have 5 cubed and then square root. And then on the outside of that, we have 2x plus 1. On the right-hand side, we have 5 to the 4th power over 3 because of the cube root there. So that means on the left-hand side, we have 3 over 2 and then 2x plus 1 multiplied together. On the right-hand side, we have 4 over 3. So just like in example B, we're going to multiply everything by 6 once again. So on the left-hand side, we have 9 times 2x plus 1. On the right-hand side, we have, let's see here, 8. Right, 6 divided by 3 is 2, 4 times 2 is 8. All right, so from here, we can distribute everything, so that means we have 18, sorry about that. Scroll down a bit. We have 18x plus 9 equals 8. That means that 18x is equal to -1 when we subtract 9 from both sides. So finally, x is going to be equal to -1 over 18. And that's it. So yeah, so we reviewed the exponent laws from before, and then introduced the idea of using common base to solve exponential equations of a certain type. And that's it for today. So once again, thank you for listening.